Hello, this is the first video for Chapter 2, Section 3 for Math 0302 beginning algebra. It's called Solving Linear Equations. A new step. If the equation has more than one fraction, clear the equation of fractions first by multiplying each term by the LCD, the least common denominator. Here's the thing about that. Even if it has just one fraction, you can actually go ahead and clear that out by multiplying by that LCD, which is that denominator itself. Now, these are some simple rules for, well, I say simple, they're just some rules for solving linear equations. Number one says clear fractions and decimals. For fractions, you will multiply each term by the LCD. For decimals, you'll multiply each term by a needed factor of 10, how many ever you need. Number 2 says distribute to clear the parentheses. Number 3 says combine like terms. Number 4 says move the variable terms to one side of the equation and the constant terms to the other, and simplify. One variable term equals one constant term. In other words, you want to get it to look like this. AX equals B. The fifth step is to divide by the coefficient of the variable, and the sixth step is to check the solution. Now, I want to talk about numbers 2 and 3 here. Basically, what this means is simplify both sides of the equation. That's really all it says. Okay, so the first is to clear any fractions and decimals. The next two is to simplify. The fourth one is to get everything into the form of AX equals B. That means that you need to add or subtract things to get into this form, and only once you're here will you divide by the coefficient in front of x, okay, in front of the variable, or multiply by the reciprocal, which is the same thing. Okay, practice 1. We're going to solve and check each of the following. The first one is 2 times 4a minus 9 plus 3 is equal to 5a minus 6. Notice that we need to simplify first, so we're going to distribute this 2 to both of those terms. 2 times 4a is 8a, 2 times negative 9 is negative 18. Then I have that plus 3 is equal to 5a minus 6. And yes, sometimes my a's and 9's look a little bit the same. Let me make that a little bit more clear. There we go. Now, on the left-hand side, I still need to combine those two. I need to rewrite the 8a. So 8a, then negative 18 plus 3, well, subtract, so 18 minus 3 is 15. And then 18 is negative, so that makes that minus 15, is equal to 5a minus 6. Now I need to get all a's on one side and everything else on the other. I'm going to start out by getting this 5a moved over here to the 8a. Now remember, because of this, we need to subtract 5a from both sides. Now I'm only subtracting because that's a positive 5a. If it was a negative 5a, I would have added 5a to both sides. So that gives me 8a minus 5a, and 8 minus 5 is 3. So that's 3a minus 15 is equal to, and then over here we have negative 6. Now I need to get the a by itself, which means I need to get rid of the constant term on the left-hand side. So this is negative 15, so I need to add 15. So I'm left with 3a on the left-hand side, and on the right-hand side, negative 6 plus 15. Well, that's just 15 minus 6, which is 9. Largest is positive, so this is positive. I'm going to divide both sides by 3, so that gives me divide by 3, so a is equal to 9 divided by 3, which is 3. And this is the solution, but we're going to check to make sure. We're going to plug this back into the original problem. Okay, so that's 2 times 4 times 3 minus 9 plus 3 is equal to 5 times 3 minus 6. Again, there's a parentheses on the left-hand side, which means we need to evaluate it first. And in the parentheses, there's multiplication and subtraction. So multiplication happens first. So that's 2 times 4 times 3 is 12, then minus 9, plus 3 is equal to, on the right-hand side, 5 times 3 is 15, minus 6. 12 minus 9 is 3, so that gives me 2 times 3, plus 3, and 15 minus 6 is 9. 2 times 3 is 6, so that's 6 plus 3, and 6 plus 3 equals 9. So now we got 6 plus 3 being 9, so 9 equals 9. And that checks out. Now remember, this actually is called an identity. Okay. So 3 is the solution to this equality.